Okay, Algebra 1, another video from Crickwater Productions. It's a updated calendar. You should have got this back maybe last week, April 22nd. Today's the 30th, and we're doing Unit 6. So you should be done with your castle learning. We're now doing Unit 6, beginning of Unit 6, lessons 1, 2, 3, 4. So, the 30th. Okay, what do we got here? 6x squared, I'm going to expand that out, 6x over 18. X 8 times. 4, 5, 6, 7, 8. Can we simplify this? Yeah. Well, what's 6 over 18? Hopefully you say that turns into 1/3. You could even do that in your calculator. So 1/3 is part of this answer. So I'm looking over here, it's either 3 or 4. What happens with the x's? Well, they cancel 1 for 1. I've got 6 of them. See, I would write it like this. If I was doing free response, that's the way I would write it. I got to find that answer over here. So it has to have a 6. Why do they put a negative exponent? Negative exponent. That's the same thing as this. I can bring it up here. We don't normally want negative exponents, but I can bring it up there. So this and this are the same thing. So choice 3. Okay. All right, we got power raised to a power. And again, I'm going to write that out. 3x squared times itself. Times itself. So there's no confusion here. I'm cubing it. And then I'm going to write this out 4 times. It's a little bit of work. But if you do it, you're less likely to make a mistake. All right, so 3 times 3 times 3, 27. You can use your calculator. X squared, x squared, x squared, that's 6 of them. You're adding those up, adding those. Same thing here, 2 times 2 times 2 times 2. That is 16. X, I got 4 x's. 27 times 16. You could get a basic calculator to do this. Clear all this out. 27 times 16 is a 432, and then how many x's do I have? 6 there, 4 there, I've got 10 altogether. So I'm looking for this answer, choice 2. All right, big part of this unit was exponential functions. Let's just do a quick review. A and B. A is your y-intercept, where you start. B is your multiplier. What is our base? If your multiplier is bigger than 1, you grow. And if your base is less than 1, but it's got to be greater than 0, if it's like a half or a third or a quarter or something like that, then you're going to decay. All right, so I'm just looking at this one, and hopefully you say, hey, that's a decaying one. All right, it's decaying. Where's the starting? I don't know, maybe like 7 or something like that. So let's see what we got here. A must be between 5 and 10. Yeah, the A term is definitely between 5 and 10. And the base must be less than 1. Base is less than 1. Greater than 0, less than 1. They want that. So this seems to be true. Let's check. I think this might be the answer. Let's check. A must be less than 1. Yeah, no, that's false. A must be greater than 1. Yeah, it's kind of vague. Yeah, A is definitely greater than 1. B must be between 5 and 10. Now the base, no, that's false. A is between 5 and 10. That's true. The base must be greater than 1. If it was greater than 1, it'd be growing. So that had to be choice 1. All right, here's another one, another decaying one. So which graph is correct? So again, because it's decaying, it's very similar to the last one. I don't know, that looks like about 7 again. I mean, it could be 8, could be 7, could be 8. It's definitely bigger than 5 though, so it can't be this choice. Can't be 4, can't be the 2. Could be one of these. And again, I'm decaying, so my base has got to be a small number. And you can see that there's a decimal point there. That's 0.8. It's less than 1. So this is going to decay. So it's going to be choice 4. This one's going to grow. If you put that into a graphing calculator and you graph it, you'd see it go up. All right, so this is the correct answer. So 3 and 4 are very similar. Let's go to the back. Now we got a function written in function notation. If the input's -3, what's the output? I don't know. Let's try it. So f of -3 is going to be 10 to the -3rd power. Now, without a calculator, I know this means 1 over 10, 3 times. I'm dividing by 10 3 times. Negative exponent is not repeated multiplication, it's repeated division. And 10 times 10 is 100, times 10 is 1,000, and so it's 1 over 1,000 is what I'm looking for. That's the answer, choice 1. All right, we got population of fruit fly is growing exponentially. It could be modeled by this function. Why is it growing? Because it's bigger than 1. In fact, it's growing 28% right there. All right, Which of the following represents the average rate over the first 12 hours? Now, this is a tough question. Average rate. I got to find the change in y over change in x. But first, before I can do that, I got to put 0 in, and I got to put 12 in, because they want me to find the rate of change over the first 12 hours from 0 to 12. So if you plug 0 in, you get 25, 1.28 raised to the 0. Anything raised to 0 is 1, so you're just going to get 25. That's what you started with, 25 fruit flies. 12 hours later, but we got a whole lot more fruit flies. Now, if you don't have a graphing calculator, my phone does this calculation. I have to turn it sideways, but you can do this on your iPhone or whatever phone you got. So 25, 1.28 raised to the 12th power, 800, so 483, I'm going to round that off to about 484 fruit flies. Okay, what's the rate of change? Change in P over the change in time. So we had 12 hours. After 12 hours, I had 483 fruit flies. In the beginning, I had 25. Subtract those. So 484, take away 25, gives me 459 divided by 12. About 38, 38.25 I'm getting is the rate of change. Yeah, round that off, 38.3. So choice 3. That's a tough one. That's probably the toughest one we're going to see today. All right, hot liquid is placed and it cools. See, it's cooling down. This is decaying. It can be modeled by a function where m is the number of minutes it's been cooling based on the graph below, which is the closest value of b for this model. Now, this is kind of tough, but it looks like it starts, there's 50, 60, 70. I'm thinking that's 80. So it starts at 80. And then about a minute later, is that a minute? Number of minutes. So about a minute later, I don't know, it looks like it's just above 50, right? So I just need these 2 points. So I went from 80, and then I multiplied it by something, and I got something just a little bit above 50. Maybe it's 51, approximately. So 80 times what gives me about 51? It's one of these choices. So, let's just try them. Like, I know this is the wrong answer. How do I know? Because if you take 80 and you multiply it by 2, it's going to get bigger. It's going to grow. And this is not growing, this is decaying. So, it can't be this one. It can't be that one either. It's got to be one of these two. So, is it 80 times 0.65, or is it 80 times 0.84? Well, this one gives me about 67. This one gives me 52. Remember I said I thought it was 51. It's close to 51. So it's actually 52. So I'm multiplying by 0.65. It must be this one. But these two were both good guesses. These were totally out because they're bigger than 1. Had to be one of these because I'm decaying. But I'm going down 0.65. If I multiply by 0.65, I get 52 right there. All right. Population of Albany High School can be modeled by this equation. So again, see the base is bigger than 1? We're growing. We're growing. So this will be a growth. All right, T is time from 2010. So for example, this is 2020, right? So this would be 10 years later, so T would be 10. Is the population increasing or decreasing? I kind of gave it away. It's increasing. Why? Because base is bigger than 1, greater than. That's all. If it's bigger than 1, you're growing. Explain how you can tell using the equation I just did. It's increasing because the base is bigger than 1. 1.027 is greater than 1. That's all. How do you interpret this? All right, there's no work to be done here. You just got to interpret. You don't need a calculator for this. When the input is 6, what does that mean? So in 2016, because we started in 2010, so this is 6 years later. In 2016, the population of Albany High School would be 4,107 students. The output is the population. So I'm explaining what these two things mean. 6 means 2016, 6 years after 2010, my output would be 4,107 students. That's all. Okay. So your work to do is mostly multiple choice. So you're going to write down what your choices are. You got to do a little bit of work. I try to show, especially on this one, where you got to find the, is it the average rate? Is it the average rate? Number 6. Number 6 here is like the number 6 on there that we just did. That's a tough one. So I would show a little bit of work there. All right. So do well. Stay safe.